Hi everyone. Today we will discuss related rates in differential calculus. Let me give you an example of the volume of a sphere here. Very famous formula to find the volume if you are given radius of the sphere. If you can find the derivative with respect to time, we will use implicit differentiation. So left side you have dv dt, and on your right side r is the variable, so using power rule 4 pi r squared, and since we differentiate with respect to time, we must multiply dr dt. Is okay? In this case, dv dt is the rate. Is the rate of change of the volume, right? And also this is the rate of change of the radius. So we have two rates inside a single equation, right? This one is in the inner equation. That's why we say these two rates are related rates. Okay? And using this concept, we can solve a lot of very interesting situations. Okay, first question. Air being pumped into a spherical balloon at a rate of 4.5 cubic feet. Wow, we have the first number here. What is the first number? 4.5 means the air of 4.5 cubic feet is incorporates the balloon each minute, right? So here 4.5 cubic feet per minute. Okay, every minute. And please note that that is the same as dv dt. The volume is increasing at the rate of 4.5 over 9/2. Is okay? Now, question asks us to find the rate of change of the radius. So, question asks us this one. When r is 2. So in this case, please note that you have a two variable. The rate dv dt and dr dt is related, right? So to solve the situation, we must find the equation containing volume and radius. Yes, definitely we can use this one, right? Volume of the sphere is 4/3 pi r cube, where r is the radius of the sphere. So in this equation, please differentiate both sides with respect to time, the third variable. Now you have a dv dt, right? On your right side, still r is the cube, r is the variable, so you can use power rule. Then you have a pi 4 pi r squared. And we differentiate with respect to time, so we must multiply dr dt. Good? I think we have every information. What is the dv dt? Is a 9/2 4 pi r was given here 2 squared, right? And dr dt. Good. So 9/2 equals 16 pi times dr dt. Our mission is to find the dr dt, right? So from this equation, we can find the dr dt, which is 9/32 pi unit feet per minute. Okay. So at that moment, the radius of the sphere is changing. In this case, the number 9/32 pi is positive, so we can say the rate of radius is increasing at rate of 9/32 pi feet per minute. Is that okay? Good. One more example. An airplane is flying, airplane is here, flying on a flight path. I believe flight path is this way. That will take directly above the radar tracking station. In this picture, this is the station. If S is the decreasing, wow, what is S here? S is the distance from radar station to the airplane, right? In this picture, the hypotenuse is S. Is decreasing at the rate of 400 miles per hour. So can you express this 400 miles per hour in mathematical symbol? Yeah, that's a key point, right? So here, Ts dt is decreasing, so minus 400 miles. Good. And question asks us when s is 10, okay, this is 10, what is the speed of the plane? In this case, the speed of the plane, you can use this right triangle. Since according to the path, the airplane will move this way, right? So we need dx dt. Okay, that will be the technically velocity. If we can find the velocity, we can find the speed. And one more information, when this is 8, excuse me, this is 6. And using Pythagorean theorem, this is 8, right? But please note that in this case, 6 is the constant. This is the constant, right? But 8 and 10 is not basically constant. It's some value at some specific moment. In other words, x and s is the variable. Okay, I will write down equation again containing s and x from this picture. So x squared plus 6 squared equals s squared. Good. Is okay? It's a Pythagorean theorem. Now we will try to find the derivative with respect to time. So here 2x dx dt. Derivative of 36 is 0, so don't worry about the constant part. Here 2s ds dt, right? Okay, you can fill you can plug in the number, we already know that, but always simplify first. Now x is 8, dx dt, actually that is what I want. S, at that moment s is 10, and ds dt is a negative 400. Good. So dx dt will be 10 times negative 400 divided by 8. 1, negative 50, So this will be negative 500 miles per hour. Okay, again, this is the velocity, considering the direction also. But I remember the question asks us the speed. In speed, we don't need to worry about the direction. So the absolute value of velocity will be the speed. So okay, 500 miles per hour will be the speed of the airplane at that moment. Okay, so let me briefly summarize one more time. If you have any equation containing two variables, for example, x squared plus y squared equals tan squared, or tangent theta, just for example, is x over s and so many things. Okay, if you do the differentiate with respect to the third variable, for example, with respect to time, this will be 2x dx dt plus 2y dy dt equal to 0, right? In here, derivative of tangent will be, in this case, we have 3 variables, right? Wow. Now, again, I can find the derivative with respect to time. Then what is the result of the left side? Remember that derivative of tangent will be secant squared theta, then d theta dt. Okay? Equals, and what is the form of this one? This is a quotient, so we can use the quotient rule. In your denominator, you have s squared. And now derivative of x will be 1, but don't forget dx dt minus copy x. Derivative of s will be 1, but again, don't forget ts dt, right? In any situation, if you are given one or more rates, we can find another unknown rates using this differential equation. Is it okay? Okay, thank you for watching. I hope we'll see you next time. Bye bye.